All right, good morning, everyone. I'm just going to take a minute and go over some growth and decay questions, and then also go over the questions that you had from MathSpace on your Google Doc. All right, so we are back to school this week. Back to school is in the air, so hopefully you have been watching the videos for Unit 8, Lesson 1 and Lesson 2, and filling out the Google Doc with any questions that you have either from the lessons or from the MathSpace homework. So that's a great place for you to ask questions, and we'll go through those twice a week and send out videos with answers. Remember, you can always email us with questions also. All right, so the first thing that I wanted to go over were two different ways on how to tell if a graph is a growth versus a decay function. All right, and so here is one way that I do that. In order to determine if a function is growth or decay, one thing I do is I check the base, okay? So you can check the base of the exponent. Remember, if the base of the exponent is bigger than 1, it's growth, so I'm just going to put a plus there. If it's between 0 and 1, it's decay. I'm going to put a minus there. So basically what I do is I check right here and I determine is it a growth or decay, and I put a plus or minus sign there, plus to mean growth and minus sign to mean decay. Then the next thing I do is I check my exponent. All right, so then when I check my exponent, if it's a positive exponent with your x, okay, positive specifically just with the x, that is a growth. If it's a negative, that is going to be a decay. Now notice when I'm using this particular method, I'm ignoring this number out front, the a value. I don't care if the a is positive, negative, fraction, doesn't matter. You're just using your b value and your x. So in order to determine whether it's growth or decay, you're going to look at your base and at your exponent. It's decay if one part is growth and one part is decay. It's growth if both parts are growth and the other part is decay. So basically what that means is, let's say, I'll show you on the next page, but what that means is I'm just going to assign a plus or a minus sign to the base and to the exponent. So if the base is a growth and the exponent is a growth, then you know it's going to be a growth function. If the base is a growth and the exponent is decay, you know it's going to be a decay function. If the base is a decay and the exponent is a growth, it's a decay function. If the base is a decay and the exponent is decay, that actually ends up being a growth function. So the plus is going to represent growth and the minus is going to represent decay. So that's one way to do it. The other way to do it is to look at the end behavior of your graph, okay? So if you're looking at the end behavior of your graph, okay, notice you're looking specifically just at the right-hand end behavior. Notice this right-hand end behavior is going up to positive infinity. Okay, on this graph over here, okay, if we're just looking at our right-hand end behavior, this is going towards negative infinity. Now I know that this, you might look at this one and say, oh, this is exponential decay because it's getting smaller. Well, this is going to be still considered an exponential growth because it's growing towards infinity. So you look specifically at the right-hand end behavior. Okay, so if the right-hand end behavior is going towards plus or minus infinity, then it's going to be exponential growth. Okay, so what will it look like if it's going to be decay? So what decay is going to look like is that is going to be where your graph is going towards your horizontal asymptote. All right, so this one right here is easier to see because it's starting high and it's going low. Notice how this is leveling off. Okay, the end behavior on the right-hand side is going towards your horizontal asymptote. Okay, now this one right here is a trickier because it's starting low and sort of going high, but it's leveling off towards that horizontal asymptote. So once again, look at the right-hand end behavior. If the right-hand end behavior is going towards the horizontal asymptote, okay, then that is going to be exponential decay. Okay, all right, so if you'd like a little bit of practice, go ahead and take a minute and determine if each of the graphs are exponential growth or decay. You can pause this, try this using either method, and then come back for a second and check your answer. Okay, so here's the answers using that first method, and this is saying this is decay and this is growth. So I have a growth and a decay and a growth, which makes this whole thing a decay. For this one right here, this is a growth and this is a growth, so the entire thing is a growth. This is decay and this is decay, so two decays together actually equal a growth. Okay, here we have a growth and a decay, so that means that this is going to be a minus or a decay. Here we have a growth and a decay, so together they're going to be a decay. And here we have a growth and a growth, so two growths together equal a growth. So I just wanted to also show you what that actually looks like on Desmos. Okay, so if you notice this first one, this is decay. It is leveling off towards your horizontal asymptote. For the second one, we said this one was actually decay also because this is growth and this is decay. Notice how this is on the right-hand end behavior, leveling off towards that horizontal asymptote. This one right here is growth. Both portions are growth, and the right-hand side is going off towards positive infinity. Okay, this one right here, we have a growth portion and a decay portion. And notice this one is going towards the horizontal asymptote right here, so the right-hand end behavior. This one right here, so we have a decay and a decay, and notice what happens. The right-hand end behavior is going off towards positive infinity, so that's going to make this one a growth. And then finally, your last one is a growth and a growth. So the right-hand end behavior is going up towards positive infinity. So that would make this one also a growth function. All right, if you have any questions on that, please let one of us know.